everyone, welcome to my channel. With the retirement of NASA's Space Shuttle program in 2011, the United States had relied on Russia's Soyuz spacecraft for crewed missions. However, the Crew Dragon has restored America's ability to launch astronauts from its own soil, re-establishing domestic crewed spaceflight capabilities and reducing reliance on international partners. So today, we'll be seeing the creation and all the components and aspects that make the Crew Dragon a successful crewed spacecraft. Let's start the video. The development and creation of the Crew Dragon spacecraft can be attributed to the innovative efforts of SpaceX, a private aerospace manufacturer and space transportation company founded by Elon Musk. In 2010, SpaceX was awarded funding from NASA's Commercial Crew Development Program as part of the agency's initiative to encourage the development of commercial crewed spacecraft. Utilizing their expertise and experience gained through the development and operation of the Dragon spacecraft or the Dragon 1 for cargo resupply missions to the International Space Station, SpaceX embarked on the development of the Crew Dragon program. The Dragon spacecraft had already demonstrated its capabilities in delivering cargo safely to the ISS, establishing SpaceX's credibility in the realm of space transportation. The creation of the Crew Dragon involved an extensive design and engineering process. SpaceX aimed to develop a spacecraft that not only met NASA's safety requirements, but also pushed the envelope in terms of innovation and reusability. The design incorporated state-of-the-art technology, advanced avionics, and robust life support system to ensure the safety and well-being of the astronauts during their missions. SpaceX conducted numerous tests and evaluations to validate the performance and reliability of the Crew Dragon. Unmanned missions such as Demo 1 and Demo 2 flights allowed SpaceX to gather critical data, assess the spacecraft systems, and ensure its readiness for crewed missions. In May 2020, the Crew Dragon achieved a historic milestone when it successfully launched NASA astronauts Robert Behnken and Douglas Hurley on the Demo 2 mission. This marked the first crewed launch from American soil since the retirement of the Space Shuttle program. The successful demonstration validated the capabilities of the Crew Dragon and paved the way for regular crewed missions to the ISS. Since then, SpaceX has continued to refine and improve the Crew Dragon based on the insights gained from operational missions and user feedback. The company has focused on enhancing performance, reliability, and reusability, thereby reducing the cost and increasing the frequency of crewed space missions. Now let's look about the parts of the Crew Dragon. The Crew Module or the Capsule. The Crew Module, often referred to as a capsule, is the living quarters for the astronauts during their spaceflight. It is designed to provide a safe and habitable environment, protecting their crew from harsh conditions of space. The capsules feature an advanced heat shield capable of withstanding the intense heat generated during re-entry into Earth's atmosphere. Inside the Crew Module, astronauts have access to life support systems, including environmental control and life support, which maintain a comfortable atmosphere for regulated temperature, humidity, and air quality. The module is also equipped with controls, displays, and communication systems that allow the crew to monitor and operate the spacecraft. The trunk. Located at the bottom of the Crew Dragon, the trunk is an unpressurized section that provides additional cargo capacity and houses various support systems. The trunk plays a crucial role in mission operations by accommodating cargo, experiments, and supplies destined for International Space Station. It is equipped with fixed solar panels that generate power for the spacecraft. The trunk also houses radiators to dissipate heat generated by the spacecraft systems. Super Draco engines. These engines provide the spacecraft with the capability to perform a launch abort, ensuring crew safety in the event of an emergency during ascent. Draco thrusters. The Crew Dragon has 16 Draco thrusters, in which 6 are mounted at the sides and 4 at the top inside the nose cone. The Draco thrusters are used to change the orientation of the spacecraft, and the thrusters can also change or adjust the orbit of the Crew Dragon. The engines will be used to adjust the orbit to reach the ISS and deorbit and fall back into Earth. The Crew Dragon's abort system plays a vital role in ensuring the safety of astronauts during space missions. Its abort systems are specifically engineered to provide a safe escape mechanism in case of emergencies during different stages of the mission. The primary abort system on the Crew Dragon is also known as the Super Draco system. This system consists of 8 powerful engines, each capable of producing 16,000 pounds of thrust. These engines are integrated into the side walls of the spacecraft, providing the ability to quickly propel the Crew Dragon away from the rocket in the event of a catastrophic failure during launch or ascent. The Super Draco abort system offers a unique advantage over traditional launch escape systems. Unlike traditional systems that utilize solid rocket motors, Super Draco engines use a combination of hypergolic propellants which can be easily stopped and restarted. This capability enables Crew Dragon to perform multiple in-flight abort scenarios, including pad aborts, ascent aborts, and even propulsive landings. In a pad abort scenario, the Super Draco engines rapidly propel the Crew Dragon away from the launch pad to a safe distance, allowing the astronauts to escape potential hazards on the ground. During an ascent abort, if an anomaly is detected during the rocket's ascent, the Crew Dragon can separate from the failing rocket and make a controlled descent back to Earth, protecting the crew from catastrophic event. The abort system is also designed to ensure astronaut safety during different stages of nominal missions. If an anomaly is detected after the rocket has reached orbit, the Crew Dragon's abort system can be used to perform a deorbit burn, initiate a safe return trajectory to Earth for the crew. The Crew Dragon's abort system underwent extensive testing to ensure its reliability and functionality. SpaceX conducted a series of pad abort and in-flight abort tests to validate the system's performance under various conditions. These tests involved launching an uncrewed Crew Dragon spacecraft equipped with the abort system to simulate emergency scenarios, proving the system's capabilities to protect astronauts. Crew Dragon's abort system play a vital role in ensuring the safety of astronauts during space missions. Parachutes. To ensure a safe landing upon re-entry into Earth's atmosphere, the Crew Dragon is equipped with a sophisticated parachute system. 4 main parachutes are deployed during the descent phase, slowing down the spacecraft's descent and enabling a soft splashdown in the ocean or a targeted landing on land, depending on the mission requirements. Avionics and guidance systems. The Crew Dragon is equipped with advanced avionics and state-of-the-art guidance systems, navigation and control systems. These systems provide essential data processing, flight control and guidance functions, allowing for precise maneuvering, navigation and docking with the ISS. They ensure the spacecraft operates reliably and maintains a safe trajectory throughout the mission. The parachute system of the Crew Dragon spacecraft, developed by SpaceX, plays a critical role in ensuring the safe return of astronauts during their journey back to Earth. This system is designed to slow down and stabilize the descent of the spacecraft as it re-enters the atmosphere, ultimately landing a controlled landing. The parachute system consists of 4 main parachutes, each with a diameter of about 35 meters, 116 feet. These parachutes are made of high-strength material capable of withstanding the intense forces experienced during descent. The 4 parachutes work together in a sequential deployment process to gradually slow down the Crew Dragon. During re-entry, the spacecraft descends through the Earth's atmosphere. The Crew Dragon initiates its parachute deployment sequence. Initially, 2 drogue chutes are deployed at an altitude of about 6.5 kilometers, 4 miles above the surface of Earth. These smaller parachutes stabilize the Crew Dragon and reduce its descent rate, allowing for a controlled descent. Following the drogue chutes, the 4 main parachutes are deployed at an altitude of about 1.5 kilometers or 0.9 miles above the surface of Earth. These large parachutes further deaccelerate the spacecraft, significantly reducing its speed and facilitating a safe landing. The main parachutes have a combined surface area of about 1,850 square meters or 20,000 square feet, providing substantial drag to slow down the descent of the Crew Dragon. The parachute systems undergo extensive testing to ensure its reliability and performance. SpaceX conducts a series of parachute drop tests, including both controlled and extreme conditions, to evaluate the parachute's aerodynamics, strength, and stability. These tests involve dropping mock-up Crew Dragon capsules from high altitude to simulate the actual descent and landing conditions. In terms of crew capacity, the standard configuration of Crew Dragon can accommodate up to 7 astronauts. This includes a mix of NASA astronauts and international partner astronauts, allowing for collaborative missions and maximizing utilization of the spacecraft's capabilities. The Crew Dragon features comfortable seating arrangements, life support systems, and other necessary amenities to ensure the safety and well-being of the crew during their journey. On March 2, 2019, Demo 1, an uncrewed mission for the Crew Dragon, was launched from Kennedy Space Center, Florida. The mission ended in a success. The first crewed flight Demo 2 took place on May 30, 2020 with astronauts Douglas Hurley and Bob Behnken. The first operational crewed mission, Crew 1, launched on November 16, 2020 with astronauts Michael Hopkins, Victor Glover, Shannon Walker, and Soichi Noguchi. Crew 2 was the second operational crewed mission of the Crew Dragon, launched on April 23, 2021 with astronauts Shane Kimbrough, Megan MacArthur, Akihiko Oshide, Thomas Pesquet in the Crew Dragon Endeavour. Axiom 1 was a private launch of the Crew Dragon by Axiom Space, launched on April 8, 2022 with astronauts Michael Lopez Alegria, Larry Connor, Mark Pathy, and Ethan Stibb on board the Crew Dragon Endeavour. Crew 3 was launched on November 11, 2021 with astronauts Rajachari, Tom Ashburn, Kayla Barron, and Matthias Maurer on board the Crew Dragon Endurance. Crew 4 was launched on April 27, 2022 with astronauts Kjell Lindgren, Bob Hines, Samantha Cristoforetti, and Jessica Watkins on board the Crew Dragon Freedom. Crew 5 was the fifth Crew Dragon mission by SpaceX, launched on 5 October 2022 with astronauts Nicole Mann, Jose Casada, Koichi Wakada, and Anna Kikina. On March 2, 2023, Crew 6 was launched with astronauts Stephen Bowen, Warren Hofberg, Sultan Al Nayadi, and Andy Fadiev on board the Crew Dragon Endeavour. Axiom 2 was the second space mission of SpaceX with Axiom Space on May 21, 2023 with astronauts Peggy Whitson, John Schaffner, Ali Al-Karni, and Reina Barnavi on board the Crew Dragon Freedom. And on August 26, 2023, Crew 7 was launched with astronauts Jasmine Bogbeli, Andreas Mogensen, Konstantin Borisov, and Satoshi Furukawa on board the Crew Dragon Endurance. In conclusion, the Crew Dragon spacecraft represents a remarkable achievement in human spaceflight developed by SpaceX. It showcases cutting-edge technology and innovation, prioritizing astronaut safety and mission success. The Crew Dragon is revolutionizing space exploration. It has successfully transported astronauts to and from the International Space Station, expanding our capabilities in space and paving the way for future missions. The Crew Dragon is a testament to human ingenuity and serves as a beacon of hope for a future where humanity can explore and thrive beyond Earth's boundaries. I hope this video was interesting. Take care. I'll meet you in the next video. Bye.